Right, so I'm going to talk about something called searching fast and slow, and the metaphor will become apparent as I go along. So obviously there's been a lot of talks today, and you know, all of us have used web search, and we've all had that experience where, you know, we do a search on the web and we look for something, and if we don't find it, you know, we can go to another search engine or try another search. And generally, you know, this sort of discretionary search, we all do it. But you know, the cost of getting it not quite right are not really that significant. Most of these searches are fairly sort of throwaway things. But many of us will be aware that there are professions out there for whom, and Elaine touched on this at the top of the day, and certainly both Paul's talks touched on this topic as well, is that some people need it more than others, you know, and there are professions out there for whom search is a matter of governance and due diligence and professional pride in a way in getting their search right. And obviously there are certain categories that immediately spring to mind. You know, patent searches, of course, there's a huge due diligence framework around getting that right, and you know, the cost of lawsuits and getting it wrong quite significant. Healthcare, of course, underpin, you know, as with Paul LeVay's talk, you know, the evidence synthesis process is predicated on quality searching. Then there's also, you know, recruitment and media monitoring and various other professions who rely on structured searching in many different forms. So for these professions, keyword search is not good enough. They need something that is essentially more comprehensive, more repeatable, and more transparent. Okay, and that's the kind of the background to what I'm going to be talking about for the next 20 minutes or so. Now, you're probably wondering a couple of things. Okay, so how does this process actually work? You know, maybe you're unfamiliar, maybe you're not a patent searcher or you're not a healthcare information professional. How does it work in practice? So most people will use query builders like this. Everyone's different, but they're all predicated on a couple of fundamental ideas, which is that it's a form filling exercise, number one. And the second part of this paradigm, if you like, is that essentially it's predicated on the use of Boolean strings. And these Boolean strings are entered on this form, typically in a line-by-line basis. And then you'll perhaps have controls on the form that allow you to put these strings together into what makes essentially a search strategy. And again, some people on this, on the webinar today will recognize this sort of thing as this is a search strategy from healthcare. Other people may be thinking, what on earth is this? But you remember Paul's talk at the think third in the day. He talks about how they do things at NICE. I'm sure he's very familiar with this kind of search strategy, as it's called. And this is the output of that evidence synthesis process, or at least the searching part of that evidence synthesis process. It's worth pausing a little moment at this, because these artifacts are the effort of professionals over a considerable period of time, often working together. We're incorporating a lot of specialist knowledge, and the quality of the evidence that comes out of it is highly dependent on the quality of the search, highly dependent on the quality of the thing that we're looking at now. Now, this is an example, come back. This is an example from a systematic review. You can see the reference that we see down there. And you can just, if you just look at it briefly now, you can see, you can try it, or you can almost read it. You can see that there's a set of terms here. Let's ignore the suffixes for now. They're all connected together by a Boolean expression here. There's another set of terms here. The line numbers, this is, anybody remember first generation basic with go-to statements? It's a little bit like that. You know, we're basically saying go to line 8, grab it, and then negate it with line 9. And you can see generally, I'm not going to go through every line, but you can see there's lots of Boolean expressions. And you can kind of read how it all puts together, but it starts to get a bit complicated when you get to line 31 and you think, well, 31 is a disjunction of all these lines, but then 32 is this one, and this one added, and then 33 is 32 knotted with 30, and at this point I'm kind of lost, and I've read lots of these. So my hypothesis, one of the things behind the whole searching fast and slow thing, is can we make this whole approach more transparent, more repeatable, and less error prone? Okay, so I'll just leave a thought hanging in the air with you, is that clearly this search articulates a number of different concepts that are connected together through the Boolean logic. My question to you is, how many concepts are there? How many conceptual units? I'll give you a clue. I wish you wouldn't keep doing that. I'll give you a clue. Lines 1 to 7 are being ORed together in line 8. There's a block. Okay, so my question for you is, how many blocks are there in this search? And you can refer back to it, read it, see if you can work it out. Anyway, in the interest of time, I will move on. I'll leave you with that question. So as I mentioned, healthcare is not the only one. There are lots of other professions. If you've ever taken a call from a recruiter and thought, how did they get my phone number? It's probably through your social media profile. How did they find that? Through typically a Boolean search like this. And then there's another example here. This is pattern search, okay? And this is another genuine pattern search strategy over on the left. I will ask you the same question. How many conceptual blocks are in this? Can you read it? Can you parse it? Can you make sense of it? Do you think you'd be able to debug it and maintain it? Given what I've told you about, conceptually it's relatively simple, but the format, I think, obfuscates the semantics. And there is something odd about this search strategy. And again, I'll leave that thought hanging out there. Can you see what's odd about this search strategy? And again, take a moment, read it, see if you can see what's weird about it. And here's another one over on the right. This is a traditional Boolean string. This has got no line numbers, so it's not using the old goto approach, like goto statements. But it's the same idea. Clearly there's a lot of structure going on here, and it's tricky to parse. And of course, they get bigger. This is another one called media monitoring, and this is actually a 1/10 of it. And I tried to cut and paste the whole thing, but PowerPoint crashed. So you just get the first couple hundred lines of it. So for the purpose of this talk, I'm just going to focus on one domain. I mean, most of us are familiar with evidence-based medicine, and I can gloss over a little bit of the background here because Paul Levay very usefully conveyed the background to evidence-based medicine. And the example that he gave from NICE is a classic example of how this is done. And of course, the systematic literature review is a fundamental part of the evidence synthesis process. Okay, lots and lots of professionals involved, lots of due diligence, and there's lots of data as well. If you look at the the statistics on the publications on systematic reviews or the publications on randomized controlled trials, again, we see something like a power law. So clearly lots of professionals, lots of data. This is all good so far, okay? And more to the point, there's a nice process too. You're probably wondering, how do they get from all this big data down to a small set that is used in the evidence synthesis? And again, I'll refer back to Paul's talk. I'm sure they use something very similar to this, if not this approach. This is called PRISMA, and this basically talks you through the flowchart or the process of how you get from a lot of records that you identify through various sources, primarily searching, down through screening, down through eligibility checks, down to the inclusion in your evidence base. Okay, so it's great. We've got all professionals, we've got data, we've got a process. So what could possibly go wrong? Well, this is where we start thinking about the searching fast and slow bit. So it turns out that even though Boolean strings have been around since the year dot, or at least the last 50 years, and they're the sort of lingua franca, or the primary method for structured searching, they're actually pretty substandard at communicating structure. Because as you saw from those examples that I gave, even when you do the nice formatting, it's still extremely difficult to identify among that sea of alphanumeric characters where the conceptual units are, or how the semantics is surfaced in that string. And even with your visual cues, it's still pretty tricky. And then there's the fact that these things can get very long. They can often extend over several pages. But again, the formalism, and this is also true, obviously, of code. If you think about the development of programming languages over the last, 40, 50 years, we had a similar problem, and this is exactly why object-oriented languages have been developed to handle these issues of being able to see the wood for the trees, to be able to embrace concepts such as abstraction or encapsulation or inheritance, so that we can manage the complexity in these complex logical artifacts. But unfortunately, there is no such facility in Boolean strings in their native form. And then even if you don't sort of subscribe to the analytical point of view, which I've just outlined, there's still the very pragmatic point of view, which is that typically when people do audits of published search strategies, there's a significant number of errors that are found in them. And you know, several papers that have been published on this. Here's just one from 2019 in JMLA. Again, highlighting this issue that the evidence base that's out there is based on published search strategies. Whenever they're audited, significant errors are found. So clearly a problem. And we can move on a little bit as well. And this is the commentary I'm giving you here is further commentary from Farhad Shukrani, whom some of you may know. I'm not sure if he's on the call today, but a great contributor to the thinking around what we can do to improve the process of professional search. So just listing a few of sort of Farhad's professional challenges. The peer reviewing of search strategies tends to take place behind closed forums and is typically done through distributing Word documents. Search strategy development is often done in a document-centric way. Search strategy is often shared using Word or PDF, and Word has lots and lots of issues associated with unwanted auto-conversion and unwanted auto-correction because it thinks it's text, but it's not. It's kind of, you know, it's obviously a logical formula. It's not text in the way that you and I would, you know, think of text. And there's all sorts of issues around space removal. With PDFs, of course, if you ever try to cut and paste out a PDF, there's all sorts of issues there as well. But these are the standard methods for exchanging and developing and sharing search strategies at the moment. And then there's the reproducibility of searches, and the reproducibility, you know, of scientific method more generally is a challenge within the community. Then there's the fact that Boolean logic, although it's conceptually extremely simple, there's only like 2 or 3 concepts you need to get your head around. It is counterintuitive. You know, the way that we mean or in natural language is typically, you know, an exclusive or, but it's an inclusive or in Boolean logic. And this has a similar converse problem, which often trips up users. And then there's the fact that professional searchers often have to translate their search strategies across multiple databases. And this is very typical of healthcare information professionals in particular. And Paul's talk again, great. I keep doing shout outs for your talk, Paul, but you've saved me a lot of time. He showed that they have to search across several different databases. How does this happen? Very often it's a process of painstaking manual translation of the query from one to the other. There are some automated tools out there, but they're only really what you might call semi-automated. So that's another issue. And then there's the fact that, you know, sharing search strategies, there's been lots of initiatives to, you know, to pool this collective knowledge among a community and to share best practice and templates, but none of them have really coalesced around a single platform, and none of them have really generated a kind of, you know, a publicly accessible, what I would call a GitHub for search strategies. That's my kind of vision of where we ought to be going, or where we could be going. But that hasn't happened yet, and I do think there's a real opportunity there. And then there's the other thing that, of course, again, Paul, well done, mention it again, is the idea of living search strategy. I think he talked about living reviews, I forget the term, but the whole point is that it's not something that a monolithic publication you just put out there and you go, we're done, hey, can you pay us now? It's more of, you know, that it has to be continually maintained and updated in light of ongoing evidence. And of course, this is vitally important now in the times that we're currently living in. So those are some of the issues that Farhad raises from his professional search practice. So I think I've got just a little bit of some silly nonsense coming up now, a little bit of comic relief. This probably won't work over Zoom, but I'll try it anyway. One of these interfaces is from 2010, and one of them is from 2020. They're both computer software IDEs. They're both development environments for producing code. All right, so one of them is 2010 and one of them is 2020. So hands up, who thinks it goes old then new? I'll imagine you're showing some hands. Imagine, and now hands up those who think it's going new then old. You can put it in the chat window if you like. Not that I can see the chat window, but please feel free to have a go. I can't see the chat window, so I'll just imagine that most of you have gone, oh, it goes old then new. It's pretty obvious. You know, there's a fundamental change in Well, lots and lots of things, the architecture, the anatomy, I mean, I know the visual design has changed, but that's fairly superficial. There's lots of other fundamental qualitative changes as well. So the hypothesis here is that the tooling has evolved over the last decade. Let's do the same with a search interface, okay? So one of these interfaces is from 2010. It's the same product, of course, and one is from 2020. So again, same question, does it go old then new? Or does it go new then old? And I'll imagine there's a show of hands here. And I'll ask the obvious question, who thinks there's no damn difference between the two? Everybody shows their hands, of course, because there is no difference. So I know it's a bit of a cheesy example and it's just a little bit of a fun anecdote, but I think there is a little grain of truth here, that if you look at the platforms and the tooling and the thinking behind the development of software IDEs, can't we borrow some of that, at least think about some of the rigor, think about some of the support, think about some of the designing out errors that we could put into the development for search strategies. Okay, so that kind of leads us to this point here, that actually there's more in common. I kind of think of, I haven't really pushed this angle yet, but I kind of think of search strategies a bit like code, in the sense that they're complex logical constructs. There's a lot of thinking goes into them. They're usually read many more times than they're written. They do, even if the formalism doesn't support it, they do exhibit abstraction, modularity and encapsulation. They need to be maintained, shared and optimized. These are all the challenges that the software profession has had to deal with over the past 40 or 50 years. So again, the challenge was, could we take some of the thinking, could we take some of the rigor of that and apply it to search strategy development? And that's really sort of brings me around to the kind of strap line really, which is the thinking fast and slow. My hypothesis would be that, you know, the Boolean string and the formalism that we have at the moment is essentially a procedural static formalism, and it's monolithic and it's based on textual strings. Can we not think more about turning this into something that is more transparent, that is more immediately interpretable, something that is essentially a declarative expression of the information need, that is interactive, so you can touch it, move it, get it to respond, and is it make it executable so that it's much more reproducible, and then think about objects rather than strings with all the, you know, the transparency and portability that that conveys. So that kind of leads us onto the work that I've been doing with a set of people actually around this. Whether we could visualize search strategies and use metaphors the user already understands, and separate keyword selection from the structuring part, and do all the things that we do in software IDEs, scratchpad, debugging aids, instant feedback, and support abstraction and levels of position. So that leads us to, and one last one, look for query suggestions as well. So that leads us to, but actually, we're not the first people to ask this question. There's a considerable body of prior art on this, and I'll do like 30 years worth in 2 slides. There's this one here back from 31 years ago from Anick et al, who did you know, a 2-dimensional canvas and some very influential ideas here, where it had a left to right reading. Where essentially everything left to right was a conjunction and everything vertically was a disjunction, and you know, you got the inverse video to express negation, and you have hit counts in the corner, and you could drag and drop manipulate these things. Really interesting, influential work. And again, you know, sort of later, Fishkin and Stone, 1995, you got this overlaying of like lenses, so as you could create a composite Boolean filter out of individual filters, and again, drag and drop and see the results in an interactive manner. I'll then skip over about 20 years of research to the present day. We've got this tool over here on the left, Boolio, which is created actually for recruitment search, using a sort of grid-based metaphor. We've got David Newman's stuff, the search whiteboard, again, a sort of left to right grid, done in Excel, which has a ton of adapters for lots of different databases. So again, very interesting work. And also the work from, I think it's Bond University, Queensland University in Australia. Again, lots of really great stuff here that I'm glossing over in 10 seconds. Around optimization of queries and representation of composite search queries, and their primary visualization metaphor is a tree view, as you see here. So that leads us to our own work, where essentially we've borrowed the best, or some of these ideas anyway, and tried to put them together into a cohesive package. Where essentially concepts are objects on a two-dimensional canvas, and the relationships are articulated through direct manipulation. So an immediate hit is that we've designed out the issues with the brackets, and you can't create syntactically incorrect expressions. It's simply not. It's just been designed out. And there's a set of different visualizers which I won't be able to go through today in the interest of time, but arguably that makes the semantics more transparent, and I'll do a little test of that in just a second. And of course, you can zoom in and out, so to see the overview and details, for arbitrary level abstraction to deal with that complexity. So we kind of think of this as a Lego analogy. It's almost like a playful exploration. You know, you can optimize your search strategy. You can try what ifs. You know, you can execute blocks on demand. You can enable or disable blocks like commenting out bits of code. There are lots of visual signposts to help you refine your query, you know, hit counts in the right-hand corner and various different visualizations that emphasize different aspects of the structure. At the moment, we provide native integration with 9 different databases and hope to get that up to 10 with another release coming out around Christmas time. And we also support, don't do that. We also support, can I move my mouse without the slide? Yeah, okay. We also support translations for about another 10 different databases. So even if the tool doesn't natively support your favorite database, you might find a translation. So you create your query once, then you can run it across 9 different databases and get translations for another 9 or so. Which kind of begs the question on another day, is a sort of more philosophical question, is it possible to create a universal representation for human information needs? Whereby we can articulate all the complexity and richness of that is in structured search in a single parsimonious visual language. And that's a challenge that I think is really interesting. I think there's probably a PhD or maybe even 2 in that. We've only scratched the surface. You know, our sort of solution is perhaps 80%. The last 20% is by far the hardest part of the problem. So as I said, we provide the auto translation. There's error checking built in, and so various sort of IDE type functions where if you do something that isn't allowed in this database, it provides, you know, autocomplete and various support. The sort of stuff that, you know, we kind of take for granted in the software IDE, but is relatively new for a search strategy development tool. But we recognize that even though we kind of push this alternative visual thinking approach, we recognize that 99.99% recurring of the content out there is in traditional Boolean string format. So for that reason, we've written adapters so that you can import, you know, legacy content. I call it legacy content rather patronizingly, but string-based content. And then you export back to Boolean strings if you want to just use the tool to visualize, sanity check, or peer review, or share your search. And then you can still put it back in good old Boolean if you want to. Yeah. Oh, so I asked you that question about the healthcare strategy. How are we doing time-wise? I think about another 5 minutes. And I've asked this question probably on several occasions, and only one person has ever got it right. And again, because I can't see the chat window, I won't try to do it now. But do feel free to volunteer. How many blocks you think there was in, and I've had answers all the way from 1 all the way up to 30. It's actually 4. If you visualize that search strategy, you get you basically enter it into the tool. That's how it appears. And I won't go through the detail in the interest of time, but straight away, arguably the semantics is immediately transparent that we have 4 blocks. Whether, of course, that is what the searcher intended, of course, is an open question, but that's part of the point, is putting a spotlight on the structure so that it can be more adequately debugged and understood by others. And also that pattern strategy, I asked you what was unusual about it. It's this. Line 5 is actually incorporated twice. Now, it is, of course, possible that's exactly what the searcher intended, but I kind of think not. To me, you know, I'm not a pattern searcher, and I wasn't the author of this, but that looks wacky. So I'm just wondering whether actually we've stumbled across yet another significant kind of weird oddity, stroke error, that just wasn't picked up simply because it just wasn't apparent. You know, you have to read the damn thing with what I call sort of slow thinking, and then parse it and so on and create the structure in your head and et cetera, whereas here you can just see it. So that leads us, I think I'm sort of nearly done, yeah, 2 more slides. So that leads us to a few principles, right? And this was covered in a paper that we, Andy McFarlane and I wrote back in the summer. Just to summarize a few of the things that I've covered here, the design principles behind what we're trying to do, to go from slow thinking to fast thinking, is to support transparency in the mapping between the logical structure and the physical structure. And there's a ton of things we can do here around Gestalt principles and using pre-attentive attributes to make that the semantics more apparent and to make that mapping more direct. Adopt scalable formalisms that accommodate complexity. You know, again, Boolean strings don't do that, but it is possible. Delegate lower level syntactic operations to the system functions, you know, the auto translate, the error checking, all that sort of stuff. There's no need to give that job to people. I think, you know, they can be occupied with higher level tasks. Provide real-time feedback on query effectiveness. Let them play, let them try things out, let them refine, let them optimize. Always provide undo, you know, all the way back to a blank canvas. It's simple stuff, but it's really tricky in a lot of traditional query interfaces. You know, you create this artifact and then you daren't touch it in case you break it. And provide support for collaboration and team working. You know, a lot of these professional search strategies are done on a team basis, asynchronously and distributed. Can't we have some sort of central hub where all this happens? Which leads me on to this penultimate point, is that although the talk I've given now is primarily about the technology, I do think that's only 1/3 of the real picture, and that the other part of the picture is the content. You know, I talked about GitHub for search strategies. So I really do think there's an opportunity there for sharing templates, best practices in a way that is open and transparent and publicly accessible. And ditto the community. You know, there's a huge community of different professions that I think can learn from each other and benefit from each other's experience. I kind of think of this as the Stack Overflow for search. The search community, professional search community, again, doesn't exist yet, but I think it could and it should. I think that brings me to the end. Hopefully I'm still sort of on time. So all about reimagining advanced search, designing out syntactic error, hopefully make the semantics more transparent, and provide support for all the things that professional searchers rely on: reuse, optimization, and best practice. And the key transformations behind the thinking fast and slow metaphor is to go from procedural to declarative, static to interactive, monolithic to executable, and from strings to things, you know, to borrow that expression from Google, or from strings to objects anyway. So feel free to try it for yourself. It's launched, it's live, it's publicly available, it's free to use. And we're getting good traction at the moment from various communities, particularly students, ironically enough, who want to use it for literature reviews and things like that. And there's various tutorial videos if you, you know, because first, when people land on it the first time, there is a kind of WTF moment. If you do have that experience, then just take a quick look at videos. Or ping me, you know, always happy to have a chat. Yeah, so I think that's it. I think I'm done, and I think it's 30 minutes. Great. Back to you, Ingo.
Thank you so much, Tony.